Welcome to Advanced Foundation Maths lecture series. In today's lecture, we will cover chapter 3, which is trigonometry. So let's get started. So we need to include a lot of clips from lecture 7 in basic foundation. Now next is trigonometric identities. We have already seen these formulas. So if you recall, these three are the important identities we need to memorize. The identities given in the blue one are derived formulas or derived identities from these black ones. So this would become sec theta plus tan theta multiplied by sec theta minus tan theta, and this would be equals to 1. So a square minus b square, we can factorize a plus b and a minus b. So therefore it is clear that product of these is 1. So therefore sec theta plus tan theta would be equals to 1 by sec theta minus tan theta, and vice versa, sec theta minus tan theta would be equals to 1 by sec theta plus tan theta. So the important thing to note here is that sec theta plus tan theta and sec theta minus tan theta are reciprocals of each other. So memorizing this particular thing will help solve questions faster. So whenever in a question you see either the first bracket term or the second bracket term, we try and use this. So let's see this question. It's given that if sec theta plus tan theta is 3, find sec theta, tan theta and sin theta. So we know that sec theta minus tan theta is equals to 1 divided by sec theta plus tan theta. So that would be equals to 1 by 3. Now take this as equation 1 and this as equation 2. Now let's add them. So when we add them, we will get sec theta plus sec theta will become 2 sec theta. Tan theta minus tan theta, it will get cancelled and we will be left with 3 plus 1 by 3. So that would imply sec theta would be equals to 10 by 6 or 5 by 3. Now that we know sec theta, we can also find tan theta either using the triangle law, or we can just subtract this equation from this. So let's say we subtract sec theta minus tan theta equals to 1 by 3 from this equation. So when we do that, we will get 2 tan theta would be equals to 3 minus 1 by 3. So that would imply tan theta would be equals to, so we'll take LCM and simplify, we will get 4 by 3. Now how to find sin theta? Now to find sin theta, we will make a triangle and we will write the ratios. So if tan theta is 4 by 3, so tan theta is 4 by 3, we can write this as 4k and this is 3k. Using the Pythagoras theorem, this would become 5k. So therefore sin theta would become equals to 4k by 5k, so that would be equals to 4 by 5. Another way to find sin theta is, we know the formula tan theta equals to sin theta by cos theta. Now tan theta is known 4 by 3. Cos theta is also known from here because sec theta is 5 by 3. So cos theta would be 1 upon sec theta because these are reciprocals of each other. So this would be 3 by 5. So we'll substitute cos theta and tan theta and we'll find sin theta. It will still give you 4 by 5. Next is sign of trigonometric functions. Let's say this is x-axis and this is y-axis. Now students must note that in the first quadrant all trigonometric ratios are positive. Now in the second quadrant, students must note that sine and cosec are positive. In the third quadrant, students must note that tan and cot are positive. And in the fourth quadrant, cos and sec are positive. So when we say for example, that in the fourth quadrant cos and sec are positive, so that means that sine, tan, cosec, cot would be negative in fourth quadrant. So we'll understand this more as we move forward. So just to explain this, so let's say this is y-axis and this is x-axis, and let's say someone asks us what would be sine 190 degree, would it be positive or would it be negative? So if you realize, we consider horizontal line as 0 degree, so 190 degree would be this much angle. So the line we are talking about would be something of this sort, and this angle would be 190 degrees. Now when they ask, when it is asked that sine of 190 degree would be positive or negative, we will see where 190 degree angle will lie. So that's in the third quadrant. Now in the third quadrant only tan and cot are positive, so therefore sine would be negative. So let's see this question. If angle A lies in third quadrant and 5 cos A plus 4 equals to 0, then find the value of these. So to start with, we need to find what is the value of cos of angle A or cos A. So this would be equals to minus 4 by 5. If we look at these quadrants, cos is positive here since all are positive, and in the fourth quadrant also cos is positive. So if cos A is negative, then the quadrant would be either the second one or the third one. Now it's given additionally that A is in third quadrant, so we are talking about this quadrant. Now let's ignore the sign at the moment and let's draw the right angle triangle, and let's call this as angle A. Now cos is base upon hypotenuse, so this would be 4 and this would be 5. So therefore, using Pythagoras theorem, we'll get this as 3. Now let's solve each part one by one. So first is what will be sine A. So sine A would be equals to perpendicular upon hypotenuse, so that would be equals to 3 by 5. Now we must additionally ask, would it be positive or would it be negative? So for that we need to check the quadrant. So A is in third quadrant where only tan and cot are positive. So therefore sine is negative. So this would be the answer for the first part. For the second part, tan of A, so we can clearly see tan A would be equals to perpendicular upon base. Now the question is whether it will be positive or negative. Since A is in third quadrant and tan is positive, so therefore this would be plus of 3 by 4. Now third part is finding 2 sec A minus 5 cot A. So for that we need to first find sec of A, so that would be equals to hypotenuse upon base, so that would be 5 by 4. Now since it is third quadrant, therefore sec of A would also be negative. We could have also found this using the logic that sec A is equals to 1 by cos A. Now next is cot A. Now cot A we can write as 1 by tan of A. So that would be equals to 4 by 3. Now 2 sec A minus 5 cot A would be equals to 2 times minus 5 by 4 minus 5 times 4 by 3. So that would be minus 5 by 2 minus 20 by 3. So we can take LCM. We will get 15 and this will be 40. So this will be minus 55 by 6 would be the final answer. Next we must memorize this table. So for example, if someone asks what is sine of minus of theta, so sine of minus theta is minus sine theta. Similarly, if someone asks what is sine of 90 plus theta, so that would be sine of 90 plus theta, so that would give us cos theta. Similarly, if someone asks what is tan of 270 plus theta, so that would be equals to tan 270 plus theta, so that would be equals to minus cot theta. So students are advised to memorize this table. Now what about cosec, sec and cot? So let's say we need to find sec of 180 minus theta. So we will write this as 1 by cos of 180 minus theta. So that would be equals to 1 by cos of 180 minus theta is minus cos theta. So this would be minus cos theta. So this would be equals to minus sec theta. So essentially for sec theta, the same rules will apply and so on. Now let's do this question. Now we need to simplify this. So let's rewrite these using these tables. So sine of 360 plus a would become sine of a. Cos of 270 minus a would be minus sine a. Cos of 270 plus a would be sine a, and sine of 180 plus a would be minus sine a. So therefore this whole thing would be equals to sine a plus minus of sine a minus of sine a plus minus sine a. So this would be equals to, so sine a will get cancelled. This will be minus sine a, this will be minus sine a. So that would be equals to minus 2 sine a. So that's the final answer. Next are few properties that we need to keep in mind. First point is that all the angles are measured from the positive direction of x-axis. So let's say if I have this as a line, so the angle would be measured this way. Now also note that whenever angles are measured in anti-clockwise direction, it would come out to be positive. So this would be the required angle and it would be positive. This is another line and we need to find the angle of this. So it would be this angle. Now let's say this is plus 150 degrees because we are measuring the angle in anti-clockwise direction. Now we can also measure this angle in clockwise direction. So let's see how that will work. So since this angle is 150 degree, so this angle would be 210 degrees. Now in this case, the black direction is the clockwise direction. So therefore, the angle would be 210 degree and minus sign. So it would be minus 210 degrees. Let's say I have another line here. So how would we measure this? So either it would be plus this much angle or it would be minus this angle and so on. So thing to notice, angles measured in anti-clockwise direction are taken positive. Angles measured in clockwise directions are taken negative. Now let's see the next property. So let's say this line subtends an angle 30 degree. And let's say we are talking about sine of theta. So in this case, this would be sine 30 degree. Now we all know that sine 30 degree is plus half. So therefore, this would be plus half. So I'm writing values here. Now let's draw another line from origin which is directly opposite to that line. Now if this is the case, if this is 30 degree, so this would also be 30 degree. However, since we measure the angle in anti-clockwise direction, so therefore this angle would finally become 180 degree plus 30 degree, so that would be plus 210 degrees. Now note that if sine of this angle gives you half, then sine of this angle will also give you half. The only question is whether it would be positive or it would be negative. Now we just saw that sine is positive in first quadrant and is negative in the third quadrant. So therefore this would be minus half. Now exactly the same way, if I draw a line which is something of this sort, where the angle made by the green line with the x-axis is still 30 degree with a minus sign because it's being taken in clockwise direction, and this would be 180 minus 30 degree, so that would be plus 150 degree and so on. So the value of sine of this angle would still be half and this would also be half. The only question is whether it would be positive or it would be negative. Now sine in fourth quadrant is negative, so therefore this would be minus of half. And this would be positive because sine is positive in second quadrant. So if someone asks us what is sine of 150, that would be plus half. Another way of doing the same thing is we can write sine 150 as sine 180 degrees minus 30 degrees. Now using the previous table we saw, so this would be equals to sine 30 degree, so that would be equals to half. Now let's see the other one, sine of 210 degrees, so that would be equals to sine 180 degrees plus 30 degree. Now using the table this would come out to be minus sine 30 degree, so that would be equals to minus half. So what it means is we can always do it the algebraic way, but the graphical way is fast using the quadrants. Now this was the case for the sine. Now let's see the case for the cos. So let's draw a line which is, let's say, making 45 degree and then same 45 degree here. So essentially this angle is 45, this is also 45, and this, all these are 45. So therefore the angle we are talking about is 45, and this would be 135, and this would be minus 45, and this would be minus 135, and so on. So the important thing is the value. Now we know that cos of 45 is 1 by root 2. Now since this is 1 by root 2, so therefore this would also be 1 by root 2, just negative because third quadrant cos is negative. This would also be negative because cos is negative in second quadrant. However, in the fourth quadrant it's positive, so therefore this would be plus 1 by root 2. So this is about cos. This was about sine. And similarly we can do it for other angles. Now let's see the last one for the tan graph. So let's say the angle we are talking about is 60 degree. So this angle is 60 degree, and let's draw all the lines. Now tan 60 we know is root 3, so this is plus root 3. Now in the second quadrant it will still be root 3 for that angle, however negative. This would be positive because tan is positive in third quadrant, and this would be negative, and so on. So this is how students should understand this. Now let's do this question. Now let's say we need to find cot x equals to minus 1, where x is from 0 to 360 degree, then find x. Now since cot x is minus 1, so cot x is 1 by tan x, so that equals to minus 1. So that would imply that tan x would be equals to minus 1. Now let's draw the xy axis. So let's say this is y axis and this is x axis. Now we need to find the angles where tan x is minus 1. So for the moment, let's just forget about the negative sign. Let's just forget about the negative sign and think of tan of what angle will give you 1. So answer is obviously 45 degrees. So let's just draw the 4 lines representing the 45 degrees. So this is 45 degree. Now we know that when this is 45 degrees, we know tan 45 is 1. Now similarly for this angle as well, which would be 135 degrees. How? 180 minus 45 degrees. This angle will also give us tan of 135 degree will also give us 1. The only difference would be that in the second quadrant tan is negative, and hence this would be minus 1. Now similarly for the third one, which would be this angle, now this will also give us 1, and this would be plus 1 because tan in the third quadrant is positive. Now the last one, which would be this angle, this will also give us 1. However, this would be negative since tan is negative in fourth quadrant. Now we just need to talk about from 0 to 360. So therefore x would be equals to 180 degrees minus 45 degrees, which is 135 degree. So this is one of the answers. Or x would be equals to this black angle. So since this is 45 degree, so therefore the given angle would be 360 degree minus 45 degree. So that would give us 315 degrees. So therefore x is either equals to 135 degree or 315 degrees. We can also write this in terms of pi if you want, by multiplying these terms to pi by 180. So this would give the angle in radians and so on. Now next we have these formulas where we find the trigonometric ratios of the sum and difference of different angles. So students are advised to memorize these formulas. Questions will directly come on the basis of these formulas. So let's say someone asks us what would be cos 90 plus theta. So we already know that cos 90 plus theta is minus sine theta. However, let's use this formula to see whether we actually get the same answer. So cos of a plus b will try and use this formula. So cos 90 plus theta would be equals to cos a, so that is 90 degree, into cos b, which is cos theta, minus sine 90 into sine theta. Now we know cos 90 is 0, so 0 into cos theta would be 0. So that would be equals to 0 minus sine 90 is 1, so that would be 1 into sine theta, that is sine theta. So this would be equals to minus sine theta, which is the case we already know. Now let's see another question. So we need to prove that this whole thing becomes cos of a minus b. So let's start with left hand side. Now for a moment, if you realize this is 30 plus a, this is also 30 plus a. So if you call this as alpha, so this will also become alpha. Let's call this as beta. So this would also be beta. Now if you realize this is sine alpha, if you realize this is sine cos plus cos sine. So if you look at the formulas, we can easily see that this is where we have sine cos plus cos sine. So the LHS is sine alpha cos beta plus cos alpha sine beta. Now we are going to use this formula from right to left. So this would become equals to sine of a plus b or alpha plus beta. So therefore this would be equals to sine of, now what is alpha? It is 30 plus a, and what is beta? It is 60 minus b. So this would be equals to sine 30 plus 60 would be 90 plus a minus b. Now we know sine 90 plus any angle is equals to cos of that angle using the table we saw before. So therefore this is what we got, which is the right hand side, hence proved. Next is transformation formulas. So students are advised to memorize these formulas as well. Now let's see a question using these formulas. So we need to prove that sine 5a minus sine 3a divided by cos 5a plus cos 3a is tan a. So to start with, we'll first look at numerator. So in numerator we have sine of something minus sine of something. So essentially we will be using this formula where this part would be c and this would be d. So therefore by formula this would become 2 cos c plus d by 2. So that is 5a plus 3a whole by 2, and sine c minus d by 2. So that's 5a minus 3a divided by 2. Now next let's look at denominator. So in the denominator we have cos something plus cos something. So we'll be using this formula. So this would become 2 cos 5a plus 3a divided by 2, and this would be cos 5a minus 3a divided by 2. therefore, this would become equals to, so 2 and 2 will get cancelled. This would become 8a divided by 2, so it would be cos 4a. This would be 2a divided by 2, so it would be sine of a whole divided by cos, this would be 4a, and this would be cos a. So we can see cos 4a and cos 4a will get cancelled. So we'll be left with sine a divided by cos a, which is equals to tan a, which is the right hand side and hence proved. Now let's see a question using these formulas. So we need to prove that this is equals to tan 2 theta. So if you realize this looks like of the form sine cos minus cos sine, but the angles are changing. So we cannot apply that formula. So we will think of using these formulas. So first of all, let's multiply both numerator and denominator by 2. So this would become 2 sine 8 theta cos theta minus 2 sine 6 theta cos 3 theta divided by 2 cos 2 theta cos theta minus 2 sine 3 theta sine 4 theta. Now the formula is 2 sine A cos B is equals to sine A plus B plus sine A minus B. So using this formula, the numerator will become sine A plus B, so that would be 8 theta plus theta plus sine A minus B, so 8 theta minus theta. So this is the first part. Now the second part would be sine 6 theta plus 3 theta plus sine 6 theta minus 3 theta, and then divided by, now this is 2 cos and cos, so 2 cos C cos D, so 2 cos A cos B is equals to cos A plus B plus cos A minus B. So this would be cos 2 theta plus theta plus cos 2 theta minus theta. So the last part is 2 sine, so the last part is 2 sine A sine B. So this would be cos A minus B, so that's 3 theta minus 4 theta minus cos A plus B. So this would be equals to, now if you realize this is sine 9 theta and this is also sine 9 theta, so this will get cancelled with this. Now similarly, if you realize this is cos of theta and this is cos of minus theta, note that cos of minus theta is cos theta, so therefore this will get cancelled with this. So therefore we'll be left with sine, this would be 7 theta minus sine 3 theta whole divided by cos 3 theta and plus cos 7 theta. So now we'll apply the formula sin C minus sin D. So this would be equals to 2 cos C plus D by 2 and sin C minus D by 2 whole divided by cos C plus cos D would be 2 cos C plus D by 2 cos C minus D by 2. Now if you realize 2 will get cancelled, cos of this whole angle is same as this angle, so therefore this will also get cancelled. So we'll be left with sine, this would be 7 theta minus 3 theta would be 4 theta by 2, so that would be 2 theta whole divided by, this would be cos of minus 2 theta. So this would be equals to sine 2 theta. Now cos of minus anything is cos the same angle. So this would be tan 2 theta, which is equals to RHS. So let's look at another set of formulas. So these are called multiple and sub-multiple angle formulas. So where we see, so let's look at the first formula. Let's say sine 2x equals to 2 sine x cos x. So So for example, if I need to find sine 60 degrees, I can write this as sine of 2 multiplied by 30 degrees. Now think of this x being 30 degree. So therefore, we can apply the formula. So this will become equals to 2 sine x, which is 30 degree, multiplied by cos x, which is again 30 degree. Now we know the value of sine 30 degree. So that's 1 by 2, and cos 30 degree, that's root 3 by 2. So this would be equals to root 3 by 2 is the final value. Now we already know that sine 60 degree is also root 3 by 2. So which confirms that this formula is true. Now another way of memorizing this formula is that whichever angle you have here, it gets halved when you are writing this way. So meaning, so sine 60 degree would be equals to 2 times sine half the angle written here, so that's 30 degree, and cos of half the angle written here, so that's again 30 degree. So another example is, so let's say I need to write sine of 15 degrees. So instead of following this long process, we can just write 2 sine of half the angle of this, which is 15 by 2, which is 7.5 degrees, multiplied by cos 7.5 degrees, and so on. Students are advised to memorize all these formulas. Now let's see a question. So let's say we need to simplify this. So let's say we need to simplify this. So what we will do is, we will first write tan as sine by cos. So therefore, this will become equals to sine 70 degree divided by cos 70 degree minus sine 20 degree divided by cos 20 degree whole divided by sine 50 degree divided by cos 50 degree. Now here we can take LCM. So when we take LCM, we will get cos 70 degree multiplied by cos 20 degree as the LCM, and this cos 20 degrees will get cross multiplied with this, so we will get sine 70 degree cos 20 degree minus sine 20 degree cos 70 degree. This whole divided by sine 50 degree divided by cos 50 degree. So this would be equals to, if you realize, this is a formula sine A cos B minus cos A sine B. So this will become sine of A minus B, which is 70 minus 20 degrees, and divided by cos 70 degrees cos 20 degree. Now this further multiplied by, now this is division, so this will become cos 50 divided by sine 50. Now if you realize, sine of 70 minus 20 is sine 50, so this will get cancelled with this, and we'll be left with cos 50 by cos 70 cos 20. Now we can multiply 2 on both numerator as well as denominator, so this will become 2 cos 50 degrees divided by 2 cos 70 degrees cos 20 degree. Now we can apply the formula of 2 cos A cos B. So this would become equals to 2 cos 50 degree divided by 2 cos A cos B is equals to cos of A plus B plus cos of A minus B. So that would be equals to 2 cos 50 degrees whole divided by cos 90 degrees plus cos 50 degree. Now we know that 90 degree is a standard angle and cos of 90 degree is 0. So therefore, it would finally become equals to 0 plus cos 50, which is equals to 2 cos 50 divided by cos 50. So we'll finally get 2. So this upon simplification is 2, and so on. Students are advised to practice questions given in the booklet. Thank you.